Hello. So for my Module 5 Mastery assignment, I focused on these two topics that I thought would be important for the AP exam, and they are rate and accumulation and volume of cross-sections. So first is Module 5 Lesson 3, which is rate and accumulation. So some important things to know about solving these type of problems are, first of all, just to keep in mind the sequence of antiderivative to the function to the derivative, which helps when you're thinking about rate and change in quantity over time. Another important thing to know is the definition of optimization, which is finding the absolute extrema of a function. And then finally, the fundamental theorem of calculus part 1 is very important here because, well, first of all, it's the normal version states that f of b minus f of a is the antiderivative of f of x on the interval from b to a, and note that the lowercase f's are derivatives of uppercase. But for these type of problems, we rearrange it so that the f of b equals f of a plus the antiderivative, which helps us find an ending value after considering the initial value and the change over time. So an example problem of rate and accumulation is the gravel processing problem. So the problem gives us the function g of t equals 90 plus cosine of t squared over 18, which shows us the rate of the gravel entering the gravel yard. And then it also tells us that when t equals 0, the initial value is 500 tons of gravel. And then over the next 8 hours, the factory processes gravel at 100 tons per hour. So we know that our range is going to be from 0 to 8 hours. So the first question asks to find g prime of 5 with the units and interpret the answer. So this question was calculator active, so all we have to do is type in g of 5 into the calculator and find that it equals negative 24.588 tons per hour squared. So the main work in this question is to find out what units to use and interpret the answer. So we know it's tons per hour squared because g of t, which is the rate of gravel entering the gravel yard, so that's already going to be in tons per hour. So when we find the derivative of that, that's going to be tons per hour squared because we just square the denominator. And then to interpret this, that is the rate at which the gravel is arriving. So since it is negative, we know it's decreasing every hour by 24.6 tons at t equals 5. It could be different at other times. So this question has 3 questions within it, by the way. So part B asks to find the total amount of unprocessed gravel that arrives in one workday. So that we know is from when t equals 0 to t equals 8 in hours. So we basically, all we have to do is find the antiderivative of g of t, which we remember is the rate of the gravel arriving, because the rate of the antiderivative of the rate of something will always be the amount of something. So if we're trying to find the amount of gravel, we have to just differentiate from 0 to 8 using the gravel formula, and then this can also be done in the calculator to find 825.551. So, and then remember to put units there, but this is a pretty straightforward problem. Okay, so the next part asks to find the maximum amount of unprocessed gravel in a workday. So since it's maximum, we know that we are doing optimization, and then we also can use the FTC part 1 finally, which is up there. Okay, so we're going to start by figuring out the rate of at what time the rate of gravel entering equals 100. So if we just do some simple algebra right here, because the question tells us that the plant processes gravel at 100 tons per hour. Okay, so if we just do some simple algebra right here, we can quickly figure out that t equals about 4.92 hours. And then this is going to be a good number to store in the calculator for later use so that the potential answers can be as precise as possible. So next we're going to plug in this t-value that we just found, as well as 0 and 8, because that's the upper and lower limits of integration, in order to find, and so all three of these times are potential answers for the maximum amount of gravel. And then we're just going to have to see which one is the highest. Okay, so first of all, A of 0, this one's pretty easy because we already know that G of 0 is 500 as given in the question, and then the integral in this time is 0 because we haven't been processing any gravel yet. So that adds up to 500. And then if we type in 4.92 ... using the stored value in the calculator, we get about 635.376 tons. And then finally plugging in 8, because that is the upper limit of integration, 8 hours, we get about 525.551 tons of gravel. So it's we can just look at these numbers and we can tell that the amount of unprocessed gravel is the greatest when the time equals 4.92 hours. And then remember to put units right there. Okay, so that's it for rate and accumulation. So the next topic I chose to be on the AP exam is volume of cross sections. And there's a lot to know about this topic, but here are just some basic area formulas that can help to find volume of cross sections more easily. So most of these are pretty intuitive based on like previous equations we've learned, but it's just helpful to see them written out. So first is a semicircle with the diameter on the base circle. This is assuming that the base for all of these solids is a circle, even though it could be other shapes. So this is just the pi r squared, which is the area of a circle, and then we're dividing it by 2 because it's a semicircle. Same thing with a quarter circle, but we're dividing it by 4. If we use squares, it's obviously just going to be the side squared equals the area. Right isosceles triangle with a leg on the base circle is the same as a square, but it's divided by 2. If it's the same thing but the hypotenuse is on the base circle, we have to divide it by 2 again, so it would be the side squared divided by 4. And then finally, if we have an equilateral triangle with the base on the base circle, this is sort of the most complicated one, then it will be the square root of 3 over 4 times the side squared. Okay, so here's an example problem. A solid has a circular base of radius equals 4 centimeters. Find the volume of the solid if every plane section is perpendicular to the x-axis is a square. So here's just a little graphical representation. So here's a circle, and then there's 2y, and this is perpendicular to the x-axis, and there would be like square, 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 square. Okay, so first, it doesn't give us a formula for the circle exactly, but it just says that the radius is 4 centimeters. So we can, and it's centered on the origin, so we can assume that the formula would be x squared plus y squared equals 16, because circles are always x squared plus y squared equals the radius squared. And then we can simplify this to find y, which y will basically serve like as the side in all of these where we have s. With some, so basically we're using our area formulas, but with some differentiation going on, or finding the antiderivatives, integration. Okay, so we know that the area of x, since these are squares, is just going to be the side squared. So we're going to do 2 times the y, which we found over here, squared, which we can simplify down to 4 times 16 minus x squared, and then we simply, to find the volume, just find the integral from negative 4 to 4 of of this y value, or of this area value, and then that's it. And then we can plug that into the calculator, and we get 3.41.333, and it's important to remember the units, which it told us the radius was in centimeters, so that's going to be centimeters squared. And that's the final answer. The end. Thanks for watching.